Section 5.4, Systems of Nonlinear Equations in Two Variables. We are going to have systems, but we are not going to have linear equations. So right here, that square right there tells me this is not linear. Now, we talked about linear equations before. We talked about thinking about these graphically, where normally you have two lines and where they intersect is your solution. Now you have the possibility of them being parallel lines where they never intersected, and you have the possibility of them being exactly the same line, but the majority of the time you get one solution. Now, on these problems, on a lot of these, you're not going to be expected to know the shape of the graph, but I'm still going to talk about it, and I will tell you basically what's going on, okay? Now on this one, you should recognize that this is a line, and this is a parabola. I'm not going to worry about the details. Let's just talk about possibilities here. If I have a parabola and a line, it's possible that I get two answers because I would intersect twice. It is possible to have a parabola that only hits once. So it's possible to have two solutions. It's possible to have one solution. And it is also possible to have no solutions. Okay? This is the thing that we have to be really aware of. You're not necessarily going to end up with only one solution. On some of these problems, you can end up with four. Okay, so just sort of an idea of what we expect here. You know, we have one of these possibilities. Now, what you're going to need to do, I wish I could tell you you're always going to use the addition method or you're always going to use substitution, but that's just not how this works. You're going to have to, like some of these, you're not going to be able to use addition method on at all. Others are really set up so that that works very quickly. So you're going to have to look at what you have and then decide what to do. Our main goal is to end up with one equation that only has one variable. For this first example, our second equation is solved for y. So this is set up for us to use substitution. So I'm going to take this whole trinomial and I'm going to plug it in right there for a y. That gives me 2x plus x squared plus 6x plus 7 is equal to -5. What I have here is a quadratic equation because this square term is not going to cancel out. So that means I expect that I will probably get two answers, although that's not guaranteed, probably two answers. And so I'm going to simplify this, and to solve a quadratic, we generally need a 0. So I'll have x squared. I'm going to combine these two to get plus 8x. And then I'm going to add 5 to both sides so that I get plus 12 is equal to 0. Okay. Now, this can be factored. If I think of two numbers that multiply to 12 and add to 8, positive 6 and positive 2 will work. So this factors as x plus 6, x plus 2 is equal to 0. Setting each of these equal to 0, I get x equals -6 and x equals -2. What I have going on is this situation here. I cross at two different x values. So that means I need to find the y values for each point, not just one of them. So this sort of separates into two problems at this point. I want to take this x value and plug it in somewhere so that it's easy to find the y. Let's plug into the top one, okay? So this would be 2 times -6 plus y is equal to -5. -12 plus y is equal to -5. Now add 12 to both sides, and we get y is equal to 7. So one of our solutions is the point -6, +7. Now let's find this one. I'm going to take this x value and I'm going to plug it in up here. Again, I could have done it right here as well. It's up to you. So that would be 2 times a -2 plus y is equal to negative 5. Negative 4 plus y is equal to negative 5. And y is equal to negative 1. So that means our second solution to this system is the point negative 2, negative 1. So I should be able to take negative 6, plug it in for x here, 7 here, and get negative 5. And this should check out 2 with negative 6 and 7. And then I should be able to check this one in both of them, and it should work out in both. Now what I have done is I have done a more detailed graph of this, just so you can see. Cross way up here, cross down here, we have this parabola, and that is our line. So I don't expect you to do this, but this is what's happening. Okay. So let's try this system. I have x times y is equal to negative 12, and I have x minus 2y plus 14 is equal to 0. This one I cannot use addition on because I don't have another xy term. So I'm going to have to use substitution here in one form or another. What kind of graphs are these? Well, this right here is a rational. If you divide both sides by x, you're going to see that you have a rational equation. And we know that in general, rational equations look something like this. Okay, they have asymptotes, that kind of stuff. I'm just kind of going basic here. Okay, now this is a line written in general form. Okay, so imagine drawing a line through here. It's possible that I have no solutions, right? If I go this way, I could have 2. If I go this way, I could have 2. I don't see any way to get more than 2 solutions. And I'm just talking about where they intersect. This one never intersected, it would be no solution. This one intersects here and here, here and here. We have possibilities. We might have, is it possible to have one solution? Well, yeah. If my line went through right here and just hit that one little point, I could have one solution. So none, 1, or 2, and I think that's our biggest, that's it. Okay, so if I'm going to use substitution, I need to solve one of these two equations for a variable. I like this one, I'm going to solve it for x. And to do that, I'm going to add 2y and subtract 14 from each side. And that will give me x is equal to 2y minus 14. Now I'm going to take this, and I solved this equation for x, so I need to take this and plug it into the other one. So this is going to go right there. So what I have is, technically this is in parentheses times y, but when we have a monomial, we tend to put it in the front. I'm multiplying y and x together, and this has to equal negative 12. Now to solve this, I need to distribute here, and I get 2y squared minus 14y is equal to negative 12. So I again have a quadratic that I need to solve. I will probably get 2 solutions, although that's not guaranteed. And to solve a quadratic, we want a 0. So I'm going to add 12 to both sides. Now, I'm all about making my life easier if I can. I need to factor this, but one thing I notice is that everything here is divisible by a 2. Everything here is an even number. So if I divide everything by 2, which I am allowed to do, I start dealing with smaller numbers. And yes, you're dividing the 0 by 2 as well. And smaller numbers are always better. Not to mention that it is easier to factor a trinomial that has a 1 for a coefficient of your square term. So here I'm looking for 2 numbers that multiply to a 6, that add to a negative 7, and negative 6 and negative 1 will work. So this factors as y minus 6 times y minus 1 equals 0. And from this one, I get y equals 6. And this one, I get y equals 1. So again, it looks like I'm going to have 2 points, and I will have to split it up into 2 problems. Okay, so let's do the y minus 6 version, or y equals 6, sorry. What looks easiest? To me, this first one looks easiest. If y is 6, then I have 6x equal to negative 12. So my x value would be a negative 2. So one point where these two graphs cross would be the point negative 2, 6. And again, slow yourself down. Make sure you're putting the x value and then the y value. I know you know it, but it's just a very common mistake. Okay? Now let's do the y equal to 1 version. And this would be 1x equal to negative 12. So of course, x is negative 12. So this would be the point negative 12, positive 1. And I also did this graph. Okay, it's a rational. Here's our line. And I didn't extend it out far enough, but you can see right here, one of our answers was negative 2, 6, negative 2, 6. And the other one was negative 12, 1, 10, 11, 12, 1. It appears to be, yeah, that seems reasonable. Although I didn't extend it far enough, it looks reasonable.